I think we can finally put the debate about how useful AI is for coding to rest. It is. We don't know to what level yet, but we know it can make you way faster as a developer. What we don't know yet is the impact on us. How does this affect ourselves and our skills and the things that we're capable of building? Are we running to a future where everyone is too dumb about code stuff to make changes and actually fix things because we just get used to the agents doing it? These are actual interesting and kind of scary questions, and Anthropic's now taking the time to research it themselves. They just published a new paper, How AI Impacts Skill Formation, and it's really, really interesting. They took multiple groups of developers and had them build the same project, some with AI, some without, and then checked to see how much they understood what they built and how well they could answer questions about what they built afterwards. And the results are fascinating. On average, participants in the AI group finished about 2 minutes faster, although the difference was not statistically significant. There was, however, significant differences in test scores. The AI group averaged 50% on the quiz compared to 67% in the hand-coded group, or the equivalent of nearly 2 letter grades. The largest gap in scores between the two groups was on debugging questions, suggesting that the ability to understand when code is incorrect and why it fails may be a particular area of concern if AI impedes coding development. That is scary. We all might be getting much dumber really fast. There's a lot to dig into here, and I obviously have a lot of feelings about it. Some of those feelings are bad, but some of those feelings are good. Do you know what else I feel good about? Today's sponsor. Today's sponsor is a product that I use every single day. I can only imagine how many bugs I would have shipped without it. It's CodeRabbit, the AI code review that my team chose for T3 chat, ping, and all of the other crazy things that we build. We've tried all of them, and this is what the team settled on, and honestly, I understand why. The quality of the reviews is great, the integrations are great, its understanding of us is great. You tell it you want to do something different, and it remembers and does things differently, just like a human would. It's actually better than humans at code review because it'll do much more meticulous stuff. But I'm not going to sit here and say you should replace your engineers with an AI for code review. You shouldn't do that. You should use these tools to augment your teams. How many times have you read a PR, found obvious mistakes, and then had to wait a day or two for somebody to go fix it? Flip that now. Imagine if instead of waiting days for a review, you're waiting minutes. You get the feedback, you go make the changes, and you don't bother a human until you know the code is good. This can get down to a much more granular level. Why even push until you've had the review done? That's why they now have a CLI and IDE plugin. Whether you're in VS Code, Cursor, or in your terminal, you have tools now to use CodeRabbit to review your changes before you even ship. And if you do try out the CLI reviews, you can include this in the loop for your code gen. Use something like Claude Code Codex or OpenCode, add in the reviewer CLI, and now when it makes a mistake, it will catch it and fix it before you even get bothered. It's so weirdly powerful to add code review to your loop when you're building with agents because the quality of the output code just goes up a ton as a result. There's a reason everyone's using CodeRabbit, even the Linux Foundation. Yes, that Linux Foundation. Also, Bun, Clerk, Chegg, Ashby, and so many other companies. There's a reason we all pick CodeRabbit, and it's not just because it's free for open source, which, by the way, free for open source. Figure it out now at soydev.link/CodeRabbit. Before we dig too deep into the numbers, I think it's important to better understand how the study worked and was structured. It's very important to get those things before you just go share numbers around. Because I've already seen people saying, look, this is proof AI makes you 15 to 20% dumber. Not that simple. We recruited 52 mostly junior software engineers, each of whom had been using Python at least once a week for over a year. We made sure they were at least somewhat familiar with AI coding assistance and were unfamiliar with Trio, the Python library on which our tasks were based. We split the study into 3 parts: a warm-up, the main task consisting of coding 2 different features using Trio, which requires understanding concepts related to asynchronous programming, a skill often learned in a professional setting, and a quiz. We told participants that the quiz would follow the task, but encouraged them to work as quickly as possible. We designed the coding task to mimic how someone might learn a new tool through a self-guided tutorial. Each participant was given a problem description, starter code, and a brief explanation of the Trio concepts needed to solve it. We used an online coding platform with an AI assistant in the sidebar, which had access to participants' code and could at any time produce the correct code if asked. Interesting. They're using a web interface for this. There's a lot of layers of things that are interesting here, from the mostly junior to using a library they were unfamiliar with to specifically being told and encouraged to work as quickly as possible, but also that a quiz would occur later on. So to see just like what the flow of this looks like, you have 2 groups, treatment and control. Control has no AI throughout. Treatment has no AI for the first task, which is a warm-up coding task. They do have AI for the second one, which is the core task of creating this project or solving these problems they were given. Then they have post-task quiz, which they had 25 minutes to do, and then a survey at the end about things they did, what they thought, etc. In our evaluation design, we drew on research in computer science education to identify 4 types of questions commonly used to assess mastery of coding skills: debugging, code reading, code writing, and general concepts. Our assessment focused most heavily on debugging, code reading, and conceptual problems, as we considered these to be the most important for providing oversight of what is increasingly likely to be AI-generated code. And again, the results. As mentioned before, on average, participants in the AI group finished slightly faster, but also performed meaningfully worse on the test. There are important pieces to measure here, and this is where I'm going to start my pushback. I want to talk about the 2-minute thing. When you're first learning a new environment of any form, it takes some amount of time to ramp up on it, to figure out how it works, what goes where, what key bindings function. If I have to use a computer or an environment that isn't mine, I have to spend the first 5 to 10 minutes just adjusting because I have a bunch of weird key bindings on my computer. I hate that I do this. I try to be as stock as possible on my machines, but there's a few I just can't give up. I use Carabiner heavily. It's a way to rebind your keys on Mac, and I have a handful that I live on. For example, I have caps lock bound as hyper, and then other number keys for switching between apps. So 1 is Helium, 2 is my terminal, 3 is my editor, 4 is Notion. And being able to switch between my apps with one key press like this is very, very useful when I'm doing my day-to-day work. I also have caps lock and U and O as page up, page down, and IJKL for my D-pad, so I don't have to move my hand all the way down to the arrow keys to move around in my editor. So like if I want to just go up 2, I can do it without having to move my hand over to the arrow keys or the trackpad. Just little things like that that I've built up over the years that I can't really use a computer without. And I've had this problem when I was doing job interviews, by the way, where I would go in and they would give me a computer to use during the interview, and I could barely use it because I could barely use their keyboard because it's not mine. I'm not used to it. It's not how I'm set up. If you give all of these people a brand new environment, at least half of the time is going to be spent figuring out the environment, especially in a 30-minute window. It would take me more than 30 minutes to figure out some weird AI vibe coding tool in the browser. So if half the time is setting up, some of the time is reading and figuring out the code, the only piece that's left for typing is like 5 to 10 minutes of the actual time. Obviously, the AI is not going to be that helpful there. But if you're using environments you're already familiar with, the time savings are crazy. I have had many a time where legitimate difficult work that would have taken me hours, if not days, took an agent 10 to 20 minutes. And I've had times where work that would have taken me weeks took an agent 3 to 4 hours of an overnight run. Like, you cannot measure this in a study so simply when it's in a 35-minute window and half the time is spent figuring out the tool. The number measurement for time here is, we should just throw it out. It is not valuable at all. Just let's be real. The percentage gap in their understanding, however, that is somewhat real. We definitely want to dig more into that. One of the pieces they do dig into here that I think is really important to learn from is the AI interaction modes. This isn't like a button they hit in the settings. This is how they actually used the AI. We were particularly interested in understanding how participants went about completing the tasks that we designed. In our qualitative analysis, we manually annotated screen recordings to identify how much time participants spent composing queries, what types of questions they asked, the types of errors they made, and how much time they spent actively coding. One surprising result was how much time participants spent interacting with the AI assistant. Several took up to 11 minutes, which is 30% of the total time allotted, composing up to 15 queries. This helped explain why, on average, participants using AI finished faster, although the productivity improvement was not statistically significant. This sentence should not even be in here. The fact that they're trying to measure the productivity win in a 30-minute task means the people who built this study and threw it at a bunch of juniors fundamentally do not understand how we operate with these tools. And I want to really emphasize this point. From my understanding of this study that I have read separately, my understanding is that this is interesting in the limited scope of how students and really, really, really early developers, when first introduced to an AI tool, similar to like the first time they open their IDE, how does using it with AI compare to using it without in like the limited 1 to 2 hour starting window? I do not like the fact that people are trying to project the study beyond that, especially on the speed side. I've already seen people say, look, there's proof that AI doesn't actually speed you up as a dev. Recent studies are showing a pretty consistent 30% improvement in code output year over year for developers who are using AI in real companies. So no, this is bullshit. There is parts here that we should dig into though. So I'm not trying to discount the whole thing. I'm just trying to limit the scope of how much we use this to prescribe what's going on. They do call us out a little bit. We expect AI would be more likely to significantly increase productivity when used on repetitive or familiar tasks. It goes further. It improves a lot more too when you're also familiar with the AI tools you're using and the development environment that you like. Once you get yourself in the harness and the tool set that you feel good about and get good at it, you start shipping at speeds that don't make sense. I wish I had my other laptop plugged in right now so I could show you guys. I was last night working on 4 projects at the same time with Codex. It's insane. I'm building like a new app every day right now to just test out ideas. Obviously, I'm not shipping all of these things, but I'm putting time in to experiment with different ideas to see what is and isn't possible. And I've also seen some of the best engineers I know, people building crazy libraries, having AI agents go build out an idea they have for a feature and being not just surprised that it could do it, but by decisions it made that informed them on how they would go write it by hand later. There's a story that's going to come out soon about this from a really, really talented full stack front end framework person that y'all already know and love. A lot of the AI haters know and love. And I cannot wait for him to share the story because it is crazy. Back to the study though. Unsurprisingly, participants in the no AI group encountered more errors. These included errors in syntax and in trio concepts, the latter of which mapped directly to topics tested on the evaluation. Reminder, this is a Python test. These people are making syntax errors in Python. I think I've said all I have to about the quality of the people being tested. Our hypothesis is that the participants who encountered more trio errors, namely the control group, likely improved their debugging skills through resolving these errors independently. Sure. Just to emphasize the weirdness of how people were using these tools in the study and just to be frank, the juniorness of the people who were in this study. The researchers noted that half of the AI using cohort spent most of their time literally retyping the AI generated code into their solution instead of copy pasting or manual coding. They wrote their code from scratch with light AI guidance. If you ignore the people who spent most of their time retyping, the AI users were 25% faster. I confess this baffles me. What kind of person manually retypes AI generated code? Did they not know how to copy paste? Unlikely, since the study was mostly composed of professional or hobby developers. It certainly didn't help them on the quiz score. The retypers got the same low score as the pure copy pasters. In any case, if you know how to copy paste or use an AI agent, I wouldn't use this paper as evidence that AI will not be able to speed you up. Thank you, Sean, for the observations here. Great article if you want to read other opinions on this. It'll be linked in the description, but back to my thoughts, because I have so much to say. They try to break down the different patterns in which people interact with the AI here to give you an idea of what the results were from how they used it. The patterns that resulted in the lowest scores were ones where the users, the test subjects, would rely heavily on the AI, either through code generation or debugging. The average quiz score in that group was less than 40%. They showed less independent thinking and more cognitive offloading. We further separated that into a few different groups. AI delegation, which was participants in the group who wholly relied on AI to write the code and complete the task. They completed the task the fastest and encountered fewer or no errors in the process. Progressive AI reliance, participants in the group started by asking 1 or 2 questions, but eventually delegated all code writing to the AI assistant. They scored poorly on the quiz, largely due to not mastering the concepts in the second task. And then the iterative AI debugging group. Participants in this group relied on AI to debug or verify their code. They asked more questions, but relied on the assistant to solve the problem rather than clarify their own understanding. They scored poorly as a result, and were also slower at completing the 2 tasks. High-scoring interaction patterns. We considered high-scoring quiz patterns to be behaviors where the average quiz score was 65% or higher. Participants in these clusters used AI both for code gen and conceptual queries. Generation, then comprehension. Participants in this group first generated code and then manually copied or pasted the code into their work. After their code was generated, they asked the AI assistant follow-up questions to improve their understanding. These participants were not particularly fast when using AI, but they showed a higher level of understanding on the quiz. Interestingly, this approach looked nearly the same as that of the AI delegation group, except they used the AI to check their own understanding. One other thing of note here, n equals 2. The other 3 ones before, n equals 4. 2 people did this in the study. This is not some crazy comprehensive group of people testing all sorts of theories. This is like 50 people. And out of the 50 people, 25 got to use AI, and 2 of them happened to use it in this way. 2 out of 25 is bad. That's less than 10%. But do you know why so few people used it to clarify their understanding? Remember earlier? We encouraged them to work as quickly as possible. How much effort do you expect the AI developers who are still insecure about their own abilities, who are still learning how code works, when told to write code fast, do you actually honestly expect them to use those same tools to better their understanding? And to be clear, I'm not sitting here pretending that every developer uses AI to teach themselves things. But I like to think it'd be a lot higher than 2% if you told them to be quizzed after. Like, what the fuck? It's 2 people. It's not a real useful thing. I like they're being so transparent about the numbers here, but that's 2 people. You can't drive home any real learnings from this. This is not a statistically significant study. Hey, Claude, can you contact some people and get a paper together? Yeah, actually, though. Again, there are interesting things to talk about here, but we need to be realistic. There were also the hybrid code explanation people. There were 3 of them. Participants in this group composed hybrid queries in which they asked for code generation along with explanations of the generated code. Reading and understanding the explanations they asked for took more time, but helped in their comprehension. And then there was the conceptual inquiry. Participants in this group only asked conceptual questions and relied on their improved understanding to complete the task. Although this group encountered many errors, they also independently resolved them. On average, this mode was the fastest among high-scoring patterns and the second fastest overall after AI delegation. You get the idea. They did their best to break these people into groups, but there just weren't enough people to get meaningful insights. When they created a group out of behavior of 2 people, it says all that you need to. A follow-up study I would love to see for something like this is, okay, there's a lot of things I would want to see. I would want more experienced developers. I would want a wider variety of experience in developers. I'd want a much larger number of developers, and I would want much harder tasks, ideally without the same time cap put on them. It would be so cool to see an idea for a general project. Like, I'm working on a Frame.io alternative because I'm tired of dealing with it for managing my team, and I want to fully exit Adobe. It's the only piece of Adobe software we're still using. If you're not familiar, Frame is like code review plus Dropbox for video, and it's really cool. It also sucks to use more and more every day because the site's just slow as shit. And like every time I go to it, it signs me out. I sign back in. I have to wait through 3 loading screens. I have to go through a bunch of really slow, miserable shit. It's not great. I built a fully functioning alternative in under an hour. And I spent half of that time evaluating different storage providers to see which ones would provide the best speeds on good internet connections. Because I have gigabit, my editor is 5 gig. I want to make sure we can saturate our connections with this. It'd be really cool to see a study that takes a project like that, has a group with no AI and a group with AI, and see how long it takes both to complete it, see how good the products they complete function, how solid the tech decisions they make are, and how good their understanding of the code is. I would bet for something like that, the results would vary wildly. I am promising you, as somebody who is known specifically for building applications fast and building a whole tech stack around making application development safer and faster, that's why I built T3 Stack. The goal was to make it easier to ship fast without running into errors in your final outputs. I would literally guarantee that at most skill levels, the AI-generated versions would not just come out faster, but would come out more stable and with less bugs and probably be better experiences overall. And for the junior devs, they'd have way better tech decisions too. The best devs I know are telling me about how the AI is making better decisions than them. We are past that point. And this, notice, nothing in here, not a single thing in here, has mentioned the quality of the code that was output. The word quality doesn't even come up. They also had one framing here that I have feelings on. The agent could, at any time, produce the correct code if asked. The correct code. It is possible the person who wrote this does not code much, if at all, and doesn't understand how we work as developers. If you've written code for any amount of time, you know that there's no such thing as the correct code. There are very few problems in software that can't be solved dozens, if not hundreds of different ways. If there is one correct code answer to the problem they're asking, then we should honestly throw this entire fucking study out because it's useless. Happy you guys get this, chat. There are going to be multiple correct codes. That's interesting. Correct code, there are hundreds of ways to solve most problems. Yeah, I have feelings on this. I don't think this study was done in a way that maps well enough to real world use for me to care about it beyond the potential in slight differences in use characteristics resulting in different behaviors and different learnings as a result. I do want to be careful when I'm talking about things that affect like the junior developers and people who are learning how to code right now, because it's very different from how I use AI and how I talk about it. I have been writing code for a very long time. I know a lot of things that can go right and wrong. And I've had, even in languages and ecosystems I don't understand, I'm able to get a rough idea of where things can go wrong. I'm deep in building multiple native apps with AppKit and Swift, which is a stack I've never used before. And I still have a good enough intuition of where a thing might be going wrong to steer the agent the right way, even without reading the code. That is not what you should be doing if you're still learning how to code. That is certainly not what you should be doing if you've never been paid to code yet. You still have to build up the skills. And to be clear, this does not mean you shouldn't use AI. You shouldn't use it to complete your homework for you, but you should use it to better your own understanding of things and also, at times, reach beyond your own capabilities to experiment with ideas. I have a whole video about junior devs specifically that didn't perform too great, so I will not be talking about y'all anymore because you don't actually care to get better. You just complain when I don't give you enough credit. Not every junior, just the ones who are in my comment section. There's a lot of y'all in the comment section. You're certainly writing a lot more comments and probably not writing that much code. But I do want to touch on one point from this video because I think it's really important. The htmx.org account might seem like a weird thing to cite here, but the htmx.org creator is a professor who teaches computer science in a real college. He's one of the best computer science professors I've ever met, talked to, or seen the work of. He's genuinely great. I love Carson. One of the cool things he did is give his students a custom AgentsMD file for steering their agents in a way that will help them learn instead of cheat. AI Agent Guidelines. This file provides instructions for AI coding assistants working with students in this course. Primary role, teaching assistant, not code generator. AI agents should function as teaching aids that help students learn through explanation, guidance, and feedback, not by solving problems for them. What agents should do: explain concepts, point students to relevant lecture materials, review code that students have written. You get the idea. Agents shouldn't write entire functions or complete implementations, generate full solutions for assignments, complete to-do sections in assignment code, refactor large portions of student code, provide solutions to quiz or exam questions, etc. Very much steering the models away from cheating and helping, more towards teaching and learning. This is great. I want to see more of this because the student case, the junior case, and the experienced developer case /team/enterprise case are so far separated that the attempts to talk about them like they're the same are almost insulting. Anthropic even calls this out in their conclusion section here. Prior studies have found mixed results on whether AI helps or hinders code productivity. Our own research found that AI can reduce the time it takes to complete some work tasks by 80%, a result that may seem in tension with the findings presented here. Yeah, no shit. But the two studies ask different questions and use different methods. Our earlier observational work measured productivity on tasks where participants already had the relevant skills. Also, were using the tools that they are familiar with. While this study examined what happened when people are learning something new. It's possible that AI both accelerates productivity on well-developed skills and hinders the acquisition of new ones, though more research is needed to understand this relationship. There's also one more key piece that this study doesn't touch on at all that I think is really important. Is motivation. The harsh reality of building things and doing hard stuff is that it's hard to stay through. I'm going to do my favorite analogy that you guys who have been here for a while are very familiar with: my skateboard. A lot of people have tried to skate. It's fun, it's cool, it's rad. Skateboarding is also really, really hard. Skateboarding is why I had to have my whole left hand reconstructed, and to this day I have this brutal scar for my entire left thumb having to be reattached to my hand just a few months ago. Yet I still do it. I love my skateboard. It is a thing that is very important to me. It is one of the coolest, best, most rewarding skills I have taken the time to teach myself. But there's a thing that sucks about skateboarding. It hurts. Literally. Every time you try a trick, there's a risk it physically hurts you. At the very least, it will physically exhaust you some amount. The amount of energy a skateboard takes from you is unbelievable. It also hurts you mentally a bit too, because every time you fail, you feel the failure. You see people do the tricks so elegantly, so easily, and then you go try it yourself and you can barely get the board off the ground. 95% of skaters will never even ollie. They'll never get the board off the ground the first time, because even that can take a year to learn, and more than that to learn well. Even just jumping on a skateboard is so difficult. But when you can get over that, you'll do incredible things. Skateboarding has a very strange problem where the interest in skateboarding can grow, but skateboarding itself does not. Over COVID, a lot of people were looking for new hobbies, and skateboard sales went up in a way we've never seen before. It was literally 5 times more sales than we've ever seen in the history of skateboarding. It was crazy. The issue was that all the people who bought a skateboard weren't motivated to learn how to skate. They were motivated to get something to do during COVID. Skateboard sales rely a lot on buying new boards. The wooden part, the deck on a skateboard, can be broken relatively easily when you start skating harder. I can break one in a few hours after setting it up. Usually it takes me about a week or two. On certain brands from certain things they do like carbon fiber and shit inside, they can last a couple months. But I, at my peak, probably went through 100 decks in a year. That is a big part of how skateboarding gets funded, is people like me having to buy replacements for the parts that we break, and then that money is used to continue to pay skateboarders to do harder things, to encourage more people to skate, and you get the flywheel. It was assumed when this huge surge in skateboard sales happened that there would be some continued interest. But 99% of the people plus who picked up skateboarding during the COVID break never got good enough to break a board. That huge surge in board sales resulted in no long-term sales. And a ton of skateboard companies that I've loved my whole life went out of business. I've rode the exact same board for 15 years, and you can no longer buy them because the company foreclosed because they produced too much stock thinking that the sales would continue, and then they didn't, and now they're dead. So why the fuck am I so deep in talking about skateboards? It's why I do hard things. The fact that when I was young, I learned that to do really cool, rewarding shit that makes you feel this special way, you had to be willing to get hurt. You had to be willing to feel stupid. And my skateboard taught me that feeling dumb is actually good because it means you'll feel smart soon. And if you don't feel dumb, you're not pushing yourself. But there are limits to this. If it takes you a month to learn how to ollie, you're much more likely to continue skating than somebody who it takes 3 months for. Because the person who it takes 3 months for is 3 times more likely to give up before they get there. This is a thing I think about a lot. On one hand, I love things that have these hard filters where it's hard enough to get into that everyone doing it is really good. I love the fact that this existed for so long in programming. Anybody with real open source work got there because they cared too much and got over the moments where they felt dumb to get there. Anyone who can do a trick down a stair set or a handrail got there because they pushed through the feeling of this is too hard, I'm gonna get hurt, this isn't worth it. And they pushed through it until they could do that thing. On one hand, this means the people who make it through are exceptional. On the other hand, there are lots of people who could be exceptional that give up because they don't have a good feeling early enough. And I do think for a lot of things, especially places where we don't have enough people doing the thing, making it easier to have that first, oh shit, I might actually be able to do this moment is valuable. If it was easier to land your first ollie and harder to land your first kickflip, there would be way more skaters. Because if we have the timeline of how long it takes to feel good about skateboards, it's probably going to be the first ollie. And if we say the first ollie happens in 3 months, and we say the first kickflip happens in, 6 months, think about all of the people who fail before they get here. By the time you get to the first ollie, you've already lost 70% of the people. But the first kickflip, a lot more survive. I personally don't know any person who can ollie but can't kickflip. I know a few that are like, they've done a few ollies that are sketchy but work, and they got close to a few kickflips. But I don't know a whole lot of people that made it to this point that didn't make it to this point. So imagine this hypothetical world where getting the board off the ground was easier than it actually is. Let's say the first ollie didn't take 3 months. Let's say it took 2 weeks. Suddenly, this gets moved way, 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 way further to the front. And if that drop-off rate was consistent, I would suspect the result there is that you get a much higher percentage making it all the way through. And even if you move the kickflip way further along, let's say you move this to 9 months, the fact that you had that first, oh shit, maybe I can do it moment so early means that that huge drop-off curve gets smoothed out and a lot more people make it to the end. Now let's replace ollie and kickflip with hello world and usable app. Do you understand now? If AI tools allow a developer to not feel stupid for as long initially, the likelihood that they make it through goes up exponentially. I can tell you from experience, knowing a lot of people who were really into tech, that like built their own computers, that love that stuff, that tried like installing Linux on the computer or like building a small app for a game they played, that gave up because the initial learnings was just too much and they felt too dumb for too long. If you can give them a taste of the reward earlier, they will survive longer. Trigger warning for those who are sensitive to animals being hurt. We're about to talk about a rat study that involves rats dying, but I think it's actually really useful for showing biologically that we are built to use hope. The experiment was done in the 1950s, where domesticated rats were placed in a bucket of water to see how long they would swim before they drowned. On average, they would give up and drown within 15 minutes, but they did a separate trial where just before the rats were about to drown, the researchers rescued them, dried them off, let them rest for a while, and then placed them back in the water. When those rats were pulled out once and put back in, they would swim for more than 60 hours instead of the 15 minutes before they gave up before. Once the rats were saved, they developed a sense of hope. And I want to make sure this is, as grim as it is, that this is the point that I emphasize here. If you get a little bit of hope early on where you were about to give up, the likelihood that you keep going is exponentially higher. It just is. That's a fact. And if AI tools are the equivalent of being pulled out of the water before you drown the first time, that is dark, but that is the world. The world's a dark place, and you need hope and motivation to push through it. If the AI keeps you from developing motivation, then it's not useful. But if the AI keeps you from losing motivation, it is incredible. And quick shout out to the lab mice that have made the world as much better as it is, as we were saying. If you compare two people who built an app, one who vibe coded it and one who wrote it by hand, obviously the one who didn't vibe code is going to be more likely to succeed in the field. But if you take two people who are starting programming One used AI to get something useful early, and the other didn't, the one who didn't is more likely to give up. And I want to make sure we find a balance when we talk about these things. Like on one hand, you shouldn't use AI tools to avoid learning, but on the other, you shouldn't spend so much time in that space where you feel dumb that you burn out and quit. If AI can unblock you, if AI can accelerate you a bit, if AI can get you excited about code again, it's probably worth doing. That doesn't mean you should replace everything with it. It doesn't mean you should outsource your brain. It means you should reach a little further than you might be capable of so that you can see things that you might not have been able to and feel things that you might have given up before you could. Everyone needs to feel good about the work they're doing sometimes. And if AI helps you feel better faster, use it in moderation. Thank you for once again letting me rant about skateboards a bit. It's my favorite thing. I'm always happy when you do it. Hope this was helpful for somebody. And until next time, peace, nerds.